I have been using Tlyard's V2L for 3 weeks. It allows me to turn my Tesla battery into a power source. I posted a previous video. It was kind of a commercial, if you will. It was a little bit hyped, maybe overhyped, but people thought that it was kind of not genuine or that it was kind of a promo commercial. And it is true. It's a brand new product. I was very excited. I put a lot of time and effort into that video, but I am an engineer. I am a mechanical engineer, but my work involves electrical engineering. So I work with motor starters, and that includes the magnetic contactors, the overload relays, inverters, also known as variable frequency drives. I work with induction motors, permanent magnet motors. I work with all sorts of circuit breakers, a lot of electrical components, and mainly the high-end automation. I'm in industrial automation. So I wanted to follow up on the V2L to talk about some of the technical aspects and why I believe this is a very safe product for you to use. First of all, I have to put this out there. This has been out in the market in Europe now for months, and there have been 0 reported issues. Now, Tesla, how does Tesla cover this product? A lot of people are nervous about that. Well, first, I think it's safe to say that it's not going to void the warranty, the Tesla battery warranty, because it's simply an accessory. Warranties can't be voided by plugging in accessories. Also, consumer protection laws such as the Magnuson-Moss Warranty Act prevent it. Tesla would have to prove the device is what damaged the battery, and they cannot because it simply won't. If Tesla can prove the device damaged the battery, then yes. But again, they'll never be able to do that due to the safety mechanisms built into the device. The V2L provides protection against overvoltage, overload, short circuit protection, over temperature, and a low battery cutoff feature. So when your Tesla battery reaches 20%, it basically shuts itself off. On top of that, and this may not be a big deal, the device itself is flame retardant. Now, of course, if there are any doubts or concerns, there's no problem avoiding this type of product. You don't have to purchase it. But for those that want to get a little bit extra out of their camping trips or powering their home or rescuing another Tesla vehicle that's stranded on the side of the road, absolutely, I think this device is well worth it. So what does the V2L do? Well, it's basically an inverter. What that means is it converts DC voltage to AC voltage, in this case 120 volt AC up to 16.7 amps, which is 2 kilowatts. So when you look at power, power is current times voltage. So if you take 120 volts and multiply that by 16.667 amps, you're going to get 2,000 watts or 2 kilowatts. Now, I had to check with Tlyard to find out exactly what the circuit protection is on this device, because that's, to me, the most important thing going on with this product. I've tested a leaf blower, 2 different power saws, and also a shop vac. And in all of those cases, the device shut itself off the minute the current peaked. And that indicates that the inrush is hitting the breaker's fast trip threshold, not the continuous one. And I was curious what level that current was peaking at. So what I did is I went out and bought a clamp meter. Now this allows me to measure the current, and it has a max current reading. However, what I realized is that it can't capture the instantaneous peak current because it happens so quickly. So even though it's tripping, I can't actually measure it. I'm going to show you 2 cases. I measured it with a microwave and I measured it with the leaf blower. Now, the fact that you can reset this simply by turning the power back on to the V2L, to me means that it's an electronic circuit breaker, which means it can be reset on its own. It's not a physical switch. Like if you trip a breaker in your basement, you have to go downstairs and, manually flip that lever. So the engineer replied saying that this device employs a combination of software algorithms and pure hardware control on the inverter to regulate the current. It will trip at around 19.7 amps. He suggested that using a voltage regulator to gradually increase the voltage could help get over these peak current situations where the device trips. The maximum measured current that I was able to measure with the leaf blower in the case where it was tripping was 11.44 amps. So in the case of the leaf blower, I didn't have any trip experiences when I slowly transitioned from stage 1 speed to stage 2 speed. But when I went directly from stage 0, which was off, to stage 2, which is the full blast, full speed, it would trip every single time. And in the case of the microwave, I measured 121 volts at 13.3 amps, which is 1,609 watts. I was kind of surprised that the microwave would run just fine. If you look at the specifications on Tlyard's website, they recommend a maximum of 600 watts for a microwave. In this case, the microwave was a 1,000 watt microwave. All right, so now that I've done enough talking, I'll let you enjoy these tests. Thanks so much for watching, everybody, and until the next one, have a great day. I'm back with the V2L. I have two things I'm going to test here. The microwave oven, which is 1,000 watts pull. Now, again, this V2L supports up to 2,000 watts or 2 kilowatts. And I have the leaf blower. So I have this, it's not only a voltmeter, but this measures the current. It's basically a current transformer. This is a commercial electric true RMS reader. And I'm going to read the voltage on the line. So there's the line, the ground, and the neutral. And the line is going to give me the correct current rating. I'm also going to measure the voltage, like I said, to get the overall power draw. And I'm going to do that for the microwave and then also for the leaf blower.
Tripped.
There, it tripped it. So the V2L tripped. Whenever there's an overload, it will completely shut itself off. So now that I have this connected again, I'm going to bring it to the highest setting and I'm going to capture the maximum current so that we can see exactly where it's tripping. 10 amps.
And it tripped out?
Yeah.
That's the long extension cord.
Okay, so I had this really long extension cord connected to the leaf blower, and that, I believe, was introducing a lot of extra resistance, which is probably why it tripped at 10 amps.
You took it straight up to max.
Yeah.
Okay.
And now I'm going to measure the voltage here. As you could see, there was quite a bit of voltage sag due to the inrush current. $13.3 amps. So for what it's worth, we have a couple extra data points on the V2L. Thanks for watching, and until the next one.